Greetings, everyone. So this morning's presentation will be about, or is entitled From CMOS to HDL. So last meeting, we've talked about the concept of abstraction. It's like sort of simplifying things and focusing only on one particular layer at a time. So ang mga layers nga involved dire sa atong pag-study of microprocessor and computer systems is the layers from circuits, no, to software. So this morning, we're going to answer the question, how will we go from CMOS, one ng pinakaubos gid nga circuit nga level, to at least HDL. HDL is somewhere pa man in the middle. Di pa man na siya HDL, as we have experienced, I'm sure naman mo experience last semester, is not yet the language to write application software, correct? Pero yeah, that's our goal this morning, to know yung sa nato pagkabok from CMOS to HDL. So we already have also experience with CMOS before. We've known it means complementary MOS, composed of two types of MOSFETs, the PMOS and the NMOS, or the positive MOS and negative MOS. Siguro ang reason nga ng PMOS ag NMOS to siya. So these are the CMOS logic circuits na ito na-encounter previously. Do you remember the names of these CMOS circuits? Pinakadumdum. Or sabay lang pwede mabuhat. Remember pa ba mo sa function sa CMOS nga device? Bitaw, wala na. Sige lang, okay ra, no? Usap bitaw will take advantage of the concept of abstraction para dili na to necessarily mo remember gyud, no, how CMOS circuits work. Okay? So ato na lang ning ibang label. Siguro sa pag-label na to sa mga names sa nga circuit, makabuluta sa ilahang function. Okay? So this is what we call the CMOS inverter. One input, two outputs. One input, one output, sorry, ang inverter. Looks familiar? Kung logic gate pa ni, this is the NOT gate, right? If ang input dire is 0, output will be 1. The inverse is also true. If input is 1, the output is 0. So again, we do not need to really go deeper how CMOS circuits work. Basta kay isa ani is PMOS, isa NMOS. I think this is the PMOS, kaning NMOS. If 0 ang input, the PMOS will be turned on. So mag 1 ni siya. Si the NMOS will be turned off. So mag 0. And tungod kay on ang atong PMOS, there is a direct line from VDD to Vout. Hence, ang output is 1. No? So I think wala na siya ang atong kinahanglan mabalaan regarding CMOS, specifically the CMOS inverter. This is the Nand CMOS. Okay? So if natay Nand gate, most probably morning nasa sulod sa atong Nand gate composed of 4 MOSes, 4 MOSFETs. No? Duha ka CMOS, complementary man eh. Duha ka pair of PMOS and NMOS. So NAND gate. Okay? Meaning if atong input dito is 0, 0, atong output would be 1. So sige lang, dito na ito i-cover tanan possible inputs for the NAND gate. Okay, later ito na siya i-cover po. So that's the NAND gate. This is the NOR gate. Notice and observe, nasa sila pagka-symmetrical with regard to the NAND. Nand CMOS circuit. No? So these are the basic CMOS logic circuits, the NOT, the NAND, and the NOR. So how about one lugar, sir? How about the OR gate and AND gate? So mas complex ang AND gate kaysa sa NAND gate. Kaya ang pwede naman ito makabot og AND gate using NOT and AND, di ba? Ato lang ni i-transfer ang input sa atong inverter sa outputs NAND. So nanatay AND gate tayo. Isang gyapon sa OR gate. To have an OR gate, to implement an OR gate, ato lang i-connect ang NOT sa NOR para natay OR. So these are CMOS logic circuits. So I hope, Delira, I hope this is the last time na maka-encounter tao CMOS logic circuits. So what's the use man of abstraction, no? Sige patik-patik sa CMOS. Now, the great thing about learning digital systems is that you only need to worry about two types of input, right? So, doon naman itong possible inputs sa digital systems. In this specific case, ang atong digital systems in question is ang atong computer or ang atong microprocessor. So, the only possible inputs are ones and zeros. Diba? 1 and 0. Actually, even output, no? So, output atong possible output. It's either 1 or 0, or true or false, or on or off, or high or low, or whichever. For the remainder of the semester, I think 1 and 0 atong gamitan para sa yun. So that makes things easier because ang input sa atong systems is only 1 and 0. So the same sa CMOS logic circuits, they only accept ones and zeros as inputs, or I mean on and off. Here, 1 or on means for the input, I say positive 5 volts. For the output, 1 or on means VDD. And a 0 output or off na output means ground. Okay. So unlike the inverter, which only has 1 input and 1 output, okay, predict, we have multiple circuits that are capable of having 2 inputs. 2 inputs, 2 possible inputs, A and B. Here. So these are the set of all 2 input logical functions. Let's observe. Some of these are logic gates in themselves. No? Our basic logic gates, asaman. We have the AND gate. So this is the truth table. This is what we call a truth table of the AND gate. Kani OR gate. Natay XOR, natay XNOR. Natay NAND, asang NOR dire. Dala NOR, no? NOR. So these 1, 2, 3, 4, 5, 6, these 6 truth tables na akong emphasize are only 6 of the 16 2-input logical functions. All the others, they are named, no? Some are simple, like this one, 0 and 1. Ang 0 nga truth table is no matter what's the input, 0 ang output. Ang 1 is no matter what's the input, ang output will always be 1. Some are like this, no? I-copy lang niya ang isa ka set of input, A. Kasulat. And B. Yet some of the others are are examples na of logical functions or complex. No, not really complex. Compound logical functions na like this one. A bar B, A B bar, A bar or B, A or B bar. No? So, ang mga basic delay or proper na term. Yeah, basic operations are this one ganyan akong gipang-emphasize. And or nor Nand Xor o Xnor. Parang sa mga basic. While in fact, natay separate na logic gate for these operations. Diba? For the OR, this one, muna iyahang schematic symbol. This is the OR gate. Input A, B, output Y. And gate, the NOT, although wala dire, kay to input man na slide. Nor, Nand, nor, XOR, sorry, and XNOR. So these are our basic logical functions, basic logic gates, and defined by truth tables. Sa lobat akong laptop. So logical functions could be defined by logic gates, by truth tables, and it could also be defined by Boolean equations. Diba? So again, logical functions could be defined using logic gates, of course. Truth table, Boolean equation, and I think there are some more. Let's say, for example, this one. Let's take this Boolean equation. For example, y is equal to A and B, or A bar and C. Kasi pagbasa nila ng A bar kay not A, no? Not A. A and B or not A and C. Pwede na not A, pwede na A bar. No? Depende sa preference. So how do we convert man this Boolean equation to truth table? Do you remember, class? Ilan man possible input? 3. So ABC naman no? Or ABC naman ABC. Damdam pa mo? How to convert Boolean equation to truth table? Was any idea? Pwede nyo type sa chat kung may gusto ingon.
Murag kadumdum pagamay, sir.
Sige daw, sa on man. Pag-convert from equation to truth table. Kadunong pa man kagamay. Sa man nga gamay ang nadumduman regarding ani. Nabatay analysis nga i-involved ani. Or tinambanon ni siya. Actually, I think the simplest way is to map out lang yun, no? All the possible inputs, then tanaw lang ang output. Kung titulo atong input, ano siya, mga possible inputs from 000 to 111. Isa-isa na gid ni. Although di man lagi nato nabuhaton karon tanan, ako nabot na naman ko i-copy dire. Pero it's like this, no? Example. So ang mga output niya ani is 0 1 0 1 0. O for example kani, when A, B, C is equal to 1 0 1 respectively. So what do we do? Ito lang substitute 1 0 1 1 0 or 1 bar 1 1 and 1 and 0 is 0 or 1 bar is 0 and 1 0 and 1 is 0. So 0 or 0 is 0. So 0 ni doing. And so on and so forth. So malagmala mo gid siling pamaagi to convert from truth table to from Boolean equation to truth table. I-map lang gid ang mga possible inputs. So another example. Y is equal to mahulog day gapang gamay nung review ni siya. Okay, review ni siya sa yung na-learn previously. Di pa mo gini mo itong main na kuan. Di naman to din mo duel, but part ni siya of course. A or B. Dumdum pa mo saan pag-simplify. What do we do to simplify? We use what? Use Boolean algebra and Boolean theorems, Boolean identities. Diba? Dumdum pa mo ato. Kani sila, kani nga table. So again, you don't need to memorize everything. Some of these are familiar. If you man ngayon ito memorize on, we should have a copy of this conveniently para pwede na ito refer anytime. So if we have, let's say for example, something such as this one, using theorem number number 16. 16, mas-simplify na to kaninga part sa expression. So this becomes A bar, B bar. Okay. Simplifying further, pao lang ng parenthesis diha kay end naman tanan. How about this one? Atay identity ani, A bar, A bar. Diba? Number 3. Something and same something is that something. So, simplify ni. A bar B. So, balik na putaan ni nga kamitan nato ang next na theorem para ma-simplify ni as in the end, A or B radii. No? So this is equal to A or B. So most of the time, it's important to simplify Boolean equations for us to get the most efficient circuit na pwede ma-implement. So, mo ni siya ang required, or I mean, mo ni siya ang atong required na function. So in the end, after simplification, it's just a simple OR gate lang di ay. So we can use Boolean theorems to simplify Boolean equations. So with this, next question actually is, how can we construct a function, or specifically a logical function, from the basic operations? Which are and or and not. How can we construct a logical function from these three basic operations? Before we answer that one, another example. What if bali? More common na ba nga situation is we'll start with a situation or a problem, and then dili man ta maka-come up initially o Boolean equation, di ba? More common is ang given nato is ang truth table. Sakto? Because the truth table is easily extracted from the problem or the situation. No? The same with gyapon sa inyong project, I believe, last semester. Ang next step sa inyong determination of the problem is the formulation of the truth table. Dili pa man sa equation diretso, no? Because mas closely ma-resemble the truth table ang situation. Example kanina. Example mo na yung set of outputs. Diba? Karon ng question. Inverse ka ganina. Do you still remember how to extract the Boolean equation from the truth table?
Answer kanang i-plus ba to ang tanan kanang naiwan nga output?
Okay, very good. I-plus or unsa man ang logical equivalent sa plus?
Answer OR.
Or ipang or ang mga kuan, no? Ang mga na ay ones output. Thank you. That's exactly correct. So dire, sort of with wala man inaiwan, no? Sort of review gyapon. We know na ang first na naka-highlight na terms, min terms yung ganito, di ba? Ang specific niya nga pangalan would be A bar, B bar, C bar, or not A and not B and not C. Second, A bar, B, C bar, A bar, B, C. So, ano siya? And then, ato lang ipang plus or ipang or. So, and that's it. Okay? A bar, B bar, C bar, or A bar, B, C bar, or
Sir,
A
bali
bar.
ang kwan, sir.
Ay, sorry. Ang last, no?
Yes, sir.
Yes, sir.
A, B bar, C bar. So thank you. Kana na, no? Correct naman siguro ni? No?
Yes, sir.
Now, using Boolean theorem pagani, pwede pa ni ma-simplify, no? So dili na mo itong objective this morning. No? From mere observation, simplify pa ni. Simplify pa na mawala ng A. Diba? So, yeah. It's possible na ang atong makuha after transforming the truth table into an equation is not yet the simplified form. That's why we need to perform Boolean algebra using Boolean theorems para makuha pa ang simplified form. Or there are other techniques man, diba? Like K-mapping. Siguro si computer na ang mag-simplify na, no? There are software for that man sa gyapon. So the point here is, let's say, after na simplify na ha, the point that I want to make, or the conclusion here, is all Boolean functions, Boolean equations, can be represented with or using only ands, ors, and nuts. Is this a fair conclusion? Would you agree with this statement? This one. Are and, or, and not only the basic logical functions that we need? Or na pa ba other logical functions na wala pang discover? No? Fair enough na ni. Would you agree? So yes, this is a valid na conclusion. Well, in fact, kung ato pa ganin i-implement this Boolean equation, it would look something like this. No? Dili na ko i-conjugate kaayo. And then sa or, then ay mga not, dire. Diba? Ana. So, from this example, you could see that this Boolean equation could be implemented using only ends, ors, and nuts. No? Probably less. Okay. Now, we'd like to contend now na the OR function, this one, the OR logical function, could be implemented using only the AND gate and the NOT gate alone. That could be proven using Boolean theorems. But yes, the OR gate could be na-equivalent logical function ang OR gate using only ends and nuts. Okay. And you also know ng AND gate and a NOT gate is the basic ingredient of the NAND gate. So, ang mas secondary conclusion gid nato, all functions can be represented using only the NAND gate. So, atong basic building block for our digital systems, for our computer, for our microprocessor unit is the NAND gate. All Boolean functions then can be represented using only the NAND gate. The NAND gate. So ang NAND gate ang atong basic building block for our digital system, for our microprocessor unit. So this is the NAND gate. Ano iyahang truth table? If both inputs are high, output is low, else output is 1. It is stated. Pero wala po the timingan. Kung ato pong tanawon at the circuit level, di ba? At the CMOS level, ang NAND gate sadya ang isa sa pinaka-simple, no? Na CMOS logic circuit. So the NAND coupled with the inverter, these are the only ingredients that we need to create our digital systems. The NAND gate. So example daw, what if I want to create a NOT gate using only NAND gate? What do we do? Isn't I guess? Unang atong NOT gate.
Ano to, sir? NOT gate?
How do we create a NOT gate using only a NAND gate? Remember that ang truth table sa atong NOT is if 0, 1 ang output, if 1 ang input, 0 ang output. Diba? So how will this NAND gate, which has 2 inputs, produce a NOT gate, no? Or could be made into a NOT gate?
Turn into one input, sir?
Ang effect ani is isa lang ka input pabilin. Sige itong buhaton. NAND gate man eh. Paano siya may mong NOT gate? Wala gusto mag-guess? Yan, ako na lang, no? To create a NOT gate from a NAND gate, ato lang i-wire ang iyang second input sa first input. And tada, nanatay, NOT gate. So from the truth table, what if ang atong input is 1? So meaning 1 dire, 1 po dito. If A is 1 and B is 1, Y is 0. So in effect, muna itong NOT gate. Same gyapon. If input is 0, so meaning si A is 0, B is 0, nara, output is 1. So in effect, 1 input, 1 output. Diba? So that's our NOT gate. Putang ta dire og another NAND gate. Actually, this is already an AND gate. So the CMOS level, our AND gate is composed of six CMOSes. Pat man ka CMOS ang NAND, wala mo lang NAT. So this is the AND gate. How about OR? Ato bang tuan ganina is all Boolean functions can be represented with ANDs, ORs, and NOT. And ang OR is pwede ma-create using AND and NOT. So could we create an OR gate using NAND gates? Actually, nga ni ang OR gate. NAND and duha ka NOT. But since our NOTs are made with NAND, pwede lang nga ni, no? Muna yun yung atong OR gate. You get the point? Makabuhat ta og ends and ORs using only, actually makabuhat tag end or ug NOT. Ano ka-amazing dire. We could create AND gates, OR gates, and NOT gates using only NAND gate. And if ang AND, OR, and NOT is the basic building block of further Boolean functions, ergo, the NAND gate is all we need to create complex Boolean functions. So siguro, panalan marag for your reflection or sumog additional question to ponder. How about 3-input AND using only NAND? Remember, the 3-input AND gate is di ba? So, is it possible to create a 3-input AND gate using only the NAND gate? So, common lang siguro answer ani nga question. So, moving along, last slide. So, this is the Xor gate. Suppose when we say we want to create a logical function or a Boolean function from scratch, now from scratch good, what we mean is we'll create it using NAND gates. So, natay HDL file, no? I think you've already heard man or have experience with HDL files man. So, we have an HDL file na for the NAND gate. And from that NAND gate, create taog ends, ORs, and NOTs. So an XOR gate is an example of a more complex logical function. Even though ang truth table sa atong XOR gate is na name na, no? Na siya iyang own name, which is of course called the XOR function. But looking at the XOR internally, this is what we'll find. No? This is a truth table of our XOR gate. Mag-output lang siya o low or 0 or off if all of the inputs are the same. So to implement our XOR gate, we need the OR, the AND, and the NOT. Sa karon lang nga sa karon nga moment, i-forget lang sa nato nga ang NAND gate, NAND gate. But of course, we'll be using the NAND gates man to build further complex logical functions such as this one. But supposing we already have HDL files for ANDs, ORs, and the NOTs, the NOT. How will we define the XOR gate or the XOR function using HDL? Or sa HDL niya sa iyang HDL program. So it has two parts. First is i-observe lang sa ang i-observe lang sa ang circuit ug ang partial na HDL program sa ubos. Because as what I've said, we already have an established na HDL files for the AND gate, the OR gate, and the NOT gate. Na-define na daan na ilang mga input and output are these, no? Ilang inputs is A and B. Ilang output is out, no? So fixed na ni sila nga mga parameters or mga variables. Wala tayong mabuhat ana. Kang NOT, ay ang input is in, yung output is out, no? Again, the same, wala tayong mabuhat ana. But what we could do is to define the connections or the wires. So how many connections will we define? We need to define at least the 4 other connections. This one, this one, this one, and that one. No need to define this one because this is A. Same with this one. This is B. This B is not the same sa this B class ha. Again, kaninga B is fixed na nidaan because of this HDL file sa kanang AND gate. So no need again to define this wire. No need to define this wire. The out of the OR gate is equal to the out also of the XOR gate for the XOR system. So kanilang upat ka wires na naka-highlight as red ang ato i-define. So pwede ta mag-name og pwede nato sila i-name og anything that we want. So make sure medyo sensible lang siya or dili po siya malibog, no? Dili malibog ang you, the analyst or the designer. So pwede na ganit not B, no? Yeah, I believe it's arbitrary, no? Arbitrary as of this point ang pag-name sa mga wires. Again, ang dili arbitrary is ang input at output sa mga existing na nga gates sa like the AND, the OR, and the NOT gate. Existing naman na sila. So arbitrary, permanent, fixed na. Ang arbitrary is kani NOT B. Giname siya as NOT B. This wire is named NOT A. This wire is named W1 and this wire is named W2. So observe the HDL program below. Basta nag-start gani og backslash, that means comment na siya, no? So, pwede na nato ignore. Ignore lang na siya para dili kayo ta malibog. No? Anything na include inside backslashes are just comments. No? Ignore lang na sila. So, this is how we start writing our HDL program. Chip, then the name of our function, in this case, XOR. Many braces, braces in what are the input of our XOR gate. So this is the XOR gate, bounded by the dotted line. So yung input, this A corresponds to this A, and this B corresponds to this B. Out is equal to out. This out is this out, not this out. But of course, pareha naman. No? So na-define na nato ang input-output. No? That's the first task, the definition of the input and output of our system, of our chip, or our Boolean function. Next is the parts. The definition of the parts. Focus lang tayo ng naka-purple for this moment. So pila ka parts ang i-define? 1, 2, 3, 4, 5 because we have 5 parts man pod sa atong system. 2 NOT gates, 2 AND gates, and 1 OR gate. So tanaw ang first line, no? Observe. NOT. This NOT is named as such because again, na-establish na nga mo na siya ang file name, no? File name. Sa HDL file ana nga NOT gate. So sa katong separate file, napud siya ingani, napud siya parts, napud siya definition of input output, no? But in this case, ang kato nga kani nga NOT gate, no? NOT gate 1, yang input is A. Yang output is not A. Ay kanila ang NOT 1. Ano siya ang NOT 1 na to? Si NOT 2, yang input is B, sakto. Yang input is B. Yang output is not B. This one. Si end, this end gate 1 is this end gate. A is A. B is not B. A is A, B is not B. Out is W1. Out is W1. So the same gyapon kay end gate number 2. I think easy lang man masubay, no? Di man siya lisod subayo ng HDL file-based circuit diagram. Last but not the least, ang OR gate. OR has 2 inputs, A and B. A is W1, B is W2, out is out. A W1, B W2, out is out. Okay, so that's how we write our HDL file. So dili lisod mag-define or mag-code og HDL file if nicely done ang circuit. So we could define an HDL file now before we end. No? Study 12. Is a textual, diba? Text-based na ba siya? Textual description of the gate diagram. Of course, basig mo ingon ta nga libog pa or nato extremes, no? Libog pa man, sir, para sa iyo naman, no? But dali lang ni siya if we try to practice, no? So, siguro sa next few meetings, we'll try to practice on how to actually write HDL files for our logic gates. Ako lang i-illustrate this morning ang mga important things to do. No? First is, of course, assuming na correct na ang atong logic circuit, first step is to define the wires, no? Define the internal wires. Just like this one. Wala mo na yung mga internal wires. After defining the internal wires, and ang pag-define na, dito pa ni sa pen and paper may tabo. No? Sa pen and paper ni may tabo. So natay freedom to use whatever name or label that we want. So after the internal wires are defined, should name our chip. Hindi na ito itong chip. Define na ito sa ilang mga input. Define na sa ang output, if ever daghan. And then, the parts are the definition of the logic gates that are inside this Boolean function. So again, practice lang din, no? We'll try to practice more as we progress. And then again, I might post something ninyong buhaton sa e-learn. So try to keep a lookout lang. Related ani, no? Logical function to HDL file. Maybe i-write ninyo sa notepad siguro. Sa notepad. So dali ni siya sa notepad ibuhaton. Okay. So, any questions? I hope na kita lang nato, no? Nakita na nato ang pag-transform from the CMOS circuit to the HDL file. No? Okay, tanan gates involved ani are made of NAND gates. Diba? Mabito to objective nato that all the other basic gates like NOT, AND, and OR are made from NAND gates. And our NAND gates are made from CMOS. So literally, this morning, nakita nato ang transformation from CMOS to HDL file. Okay. Questions? I'll just post a copy of these slides na akong gigamit sa e-learn. No? Ni dito. Any more concerns or questions?
None so far, sir.
And so far, okay. I hope nasabtan nila. If as of now, wala pa. Ako pang i-upload. Pero if ever na pa part sa discussion this morning na confusing, sige lang, i-review lang ng video and by that time, na-upload na ako ang notes, no, ang file. So, maybe next meeting na may more questions to come. So if wala na, we'll call it a day. It's lunchtime. So ano ta? And we'll see each other on next meeting.
Thank you, sir. Bye, sir.
Sige.
Thank you,
Bye-bye.
sir.
Bye-bye.
Salamat,
Thank you, sir.
Sige.
Sir.
You're welcome. You're welcome. Bye-bye.